So we're going to begin today with talking about how do we combine fractions without using a calculator. And we're going to start with talking about what's called the butterfly method. I'm going to forget about the sign in between, and I'm going to take 1 times 7. We're always going to start with this diagonal first, the diagonal going from left to right downward. So 1 times 7 is 7. Now I'm going to insert behind that whatever symbol was separating the two fractions. And in the second parenthesis, I'm going to take the diagonal that goes upward from left to right. So 3 times 5 is 15. In the very bottom, I'm going to take the product of the denominators. So 3 times 7 is 21. So you're going to take 3 times 7 to get 21, and up here the body of our butterfly would be a plus sign. This is 7 plus 15, all divided by 21. When I add together, I end up with 22 over 21. I know this cannot be reduced. We're not going to put it into a mixed number. If you are confused about how to reduce things other than actually looking at the factors and figuring out can we reduce, I do want to show you a simple trick on the calculator that can help us. Please type in 22 divided by 21 on your calculator. And instead of pressing enter, I want you on the left-hand side to find the math key. Please hit it once and press enter twice. If it reduces to 22 over 21, that tells you that this particular fraction, even though it's improper, cannot be reduced any further. This is my final answer. Let's try another one. Let's try 2 divided by 3. Subtract, and let's go with 2 over 7. Again, I'm going to forget about the symbol that's in between, so sometimes students just choose to cover it up. I always go with this diagonal first. So 2 times 7 is 14. Now I drop in the symbol that separates the two fractions, that is subtraction, and I do the second diagonal. 2 times 3 is 6. In the denominator, we'll always do the product. 3 times 7 is 21. 14 subtract 6 is 8. And 8 divided by 21 would be our final answer. We do need to make sure it's put into simplest form. We can quickly do that on the calculator, and I'll show you how we can do it by hand in just a second. We have 8 divided by 21, hitting math, fraction, enter, enter. We see that you get the exact same fraction. That tells us 8 over 21 cannot be reduced any further. Okay, you have cups at your desk. If anybody does not have cups at their desk, please raise their hand at this time. Okay. You are going to be working with the girls right behind you. All right, so for this next problem, you have cups. They should be separated, red and green. As I walk around, if I don't hear enough cooperation together, I put red cups up. If you're doing great talking together, your speed, your accuracy does not matter. You'll get a green cup. You have 2 problems here to work on with your partner. Here they are. Please begin talking with your partner. These are 2 separate problems. Speed and accuracy, not an issue. Copy done. I'm going to go over these right now. If you're confused how I'll go about doing this, I'll have 2 numbers. It'll be separated by an addition sign. By setting it up in this form, I'm already going to realize I need to put 3 different numbers in before I work about simplifying it. Always start with this diagonal first. 3 times 5 is in fact 15. Here's the addition sign, and 2 times 11 is 22. 5 times 11 is 55. Now 22 plus 15. If I add them up off to the side, I end up with 37 over 55. Give me 1 second to answer this. Hello. Now I need to ask myself, is this in simplified form? All right, give me 1 second. We have 37 divided by 55. I should hit math, fraction, enter, enter, and we can see it's simplified. It cannot have any factors that allow us to reduce it any further. This is the one I think that's going to trick students. I'm going to put my parentheses up. I know I'm going to have 3 different numbers. Forget about this sign. It's right there. So I'm not going to use this symbol when I'm doing my diagonals and finding the product. -3 times 3 is -9. I did not use this symbol. 1 times 4 is 4. I did not use this symbol. This symbol is brought down and placed in between those 2 values. 4 times 3 is 12. -9 and -4 combine to give you a -13. Negative 13 over 12 cannot be reduced. Okay, we have 2 more problems, and I'm purposely trying to trick you. Okay, are you ready? Here we go. Please go about doing these next 2 examples. So let's look at these 2 examples. Now here is the problem that confuses students. Does this negative sign, do I move it up with a 4? Does it become a negative 4 over negative 7? Like, what do I do? There's only one negative. If you recall us talking about when there's an odd number of negatives, then the value is negative. So this is a negative value. It can only be used once. When you have a fraction, I prefer you to cross out the negative if it's in the middle, to move it up into the numerator position. Okay, so I'm going to start by making my parentheses. I have subtraction. That's going to go in between. Now, I think that there's less mistakes when students immediately move down that symbol and then they cross it out. What I'm seeing students do is when they do this very first diagonal, they're including that negative sign. And so that's why I'm moving that down right away and I'm crossing it out. Negative 4 times 5. Negative 4 times 5 is negative 20. 3 times 7 is 21. The subtraction sign comes down, and now I find the product of the denominators, which is 35. When I subtract, I get a negative 41 over 35. Now, I know that cannot be broken down, but I can demonstrate that by typing in negative 41 divided by 35, hitting math, fraction, enter, enter, and we can see we get negative 41 over 35. Now, everything we worked on is adding and subtracting fractions. I want you to recognize that multiplying and dividing we do not use a butterfly method for that. When we multiply and divide, we have 2 things we can do. We can multiply just straight across. We don't need to have a common denominator. Or if you want, we can try to reduce ahead of time. For instance, I'm looking at 7 and 4. 7 and 4 cannot be reduced. 4 and 5 cannot be reduced. 3 and 7 cannot be reduced. And 3 and 5 cannot be reduced. So I'm going to multiply across. First, I'm going to push this up. And I'm going to push this up. So I'm going to multiply straight across. Negative 4 times negative 3 is 12. 7 times 5 is 35. How can I quickly reduce, since you do get to use the calculator throughout this? You could type in 12 divided by 35. Oops, so my fault. 12 divided by 35. Hitting math, enter, enter, and we still see we have 12 over 35. Let's look at the next example. Please type or write in at this time 7 over 8. Divided by 2 over 3. Please write this down. 7/8 divided by 2/3. This is a refresher from your primary grade levels. When you are dividing fractions, your first fraction, you're going to paste it in place. It's not going to move. Then we're going to turn division into multiplying, and we're not going to change the sign of the second number. We're going to take that value and we're going to take the reciprocal, which is flipping it around. And now I have a choice. Does 7 over 8 reduce? Does 7 over 2 reduce? Nope. Does 3 over 8? Nope. Does 3 over 2? So I can multiply straight across. 7 times 3 is 21. 8 times 2 is 16. Again, this cannot be reduced. Some of you factoring, you learned this freshman year, some of you 8th grade. We talked about this back in September, and now we're going to apply it as we start to work with simplifying rational expressions. So let's talk first about the difference of squares. Difference, remember, is subtraction. You're welcome just to watch. So as a review, how do we quickly do this? As a reminder, if you don't see a number out front, it is a 1. 1 breaks into 1 times 1. 4 breaks into 2 times 2. They're both perfect squares. I'm able to take this value of 2, and as long as I can split it evenly in half and I end up with whole numbers, awesome. And we have to have subtraction. So as I write this down, I have 1x in front, 2's in back, 1 is addition, 1 is subtraction. Most students do not put the 1 in front. They just write x plus 2 and x minus 2. Totally fine. So if I said to you x squared minus 9, turn to your partner without writing anything down, what would that go into? Go. Turn to your partner, go. What would it break into? X plus 3. X minus 3, okay? Now I'm gonna get into big numbers here. X squared minus 64. Turn to your partner. What does it break into? X plus 8, X minus 8, correct? How am I doing this? 1 breaks into 1 and 1. 9 breaks into 3 and 3. This breaks into X and X, and we have subtraction. All of this is good. Now let's throw a leading coefficient that is other than 1. 4x squared minus 25. Turn to your partner. What would that break into? These have to be perfect squares. Still good? Okay, now I'm going to try to confuse you. X to the fourth minus 16. X to the fourth minus 16. Oh, this is tricky. Go, talk to your partner. Go. 30 seconds. Why is, don't yell it out loud just by raising hands, why is this answer wrong? If I break this in half, so 2 divided by 2, I get a 1 and a 1. This exponent can break in half, 1 and 1. But 4 breaks in half to be 2 and 2. Okay, you ready? I want you to hold on to your red cup and the green cup that's in front of you. And I want to see right now, without looking at others as quick as you can, I want to put up an expression. I'm going to factor it. You're going to put a green cup up as quick as possible if you agree. You're going to put up a red cup if you disagree with my work. Are you ready? Give me 1 second to write. If you were watching this video, what I'm doing right now is I'm going to provide you with what I believe to be the factored version of this. Students in front of me are not going to try to stack their cups. They're going to put a green cup on top right away if they agree. They're going to put a red cup if they disagree. Okay, are you ready? Here we go. Go. Turn to your partner. Talk about why you agree or why you disagree. Go. Don't just say, yeah, she's right. Like, why do you agree? How do you know that? It works. Okay, are you ready? Put your cups side by side. You're holding on to them. Here's your expression. You're thinking about it in your head. Here's your expression. You're thinking about it in your head. Ready? Go. Okay, talk about it. Why should it be red? Go. Why should it be red? You have a red cup up. Now would it be green? Yes. Okay, cups side by side, please. Here's the next expression. No talking. Here's the next expression. No talking. And go. Red or green. I'm sorry. Don't mean to confuse you. Red or green, go. That says 50x squared minus 1. Is 50 a perfect square? And so when we are able to come up with this, we go 5 times 5 is 25. Please listen. 8 times 8 is 64. Is 25 times 25 50? No, 25 times 2 is 50. That is inaccurate. Let's look at the next one. Please look at it. No talking. Put your cup side by side. Ready? Go. If somebody has a green cup, share with them why we cannot factor it as is. Go. Has to be subtraction. Okay, I believe that is our last problem. We are now going to move into a different. Demonstrate 2 ways to factor this correctly. Both ways work. We've gone over this back in September. Many of you learned how to do this in freshman level math. And when I asked you to vote on which method made more sense to you, most of you chose what was called the AC plus B method. It's not my method of choice. I'm going to show you my method again, and you decide which one do you think works best for you. So I'm going to come off to the side, and I'm going to go 4 times negative 1 is negative 4. They combine to give you a positive 3. This tells me they're different signs, and this says the larger the number will be positive if I can find 2 numbers that work. Okay, I believe 4 and 1, larger one has to be positive. Let's check. This multiplies to equal negative 4, and it combines to give you a positive 3. Now, I'm going to do it your way. This is the way that most of you preferred. I write down the first term, I write down the last term in the trinomial, and in the middle, I take these 2 values, and I write them down. The order doesn't matter. And behind each one, I place an X for this particular problem. Now, this is the method you chose that most of you said made most sense to you, and you absolutely can continue to use this method. I can factor out an X, and I'm left with 4X minus 1. Whatever's in parentheses, I'm going to copy and paste it back. What times 4X gives you a positive 4X? And is 1 times negative 1 negative 1? It is. So I can factor this into, they both contain 4x minus 1. In front of the first is x, in front of the next one is a positive 1. And now I have correctly rewritten this original trinomial. That absolutely works. If that's your method, go at it. I prefer, after doing this, whenever the leading coefficient is different than positive 1, I got to do some more work. I prefer to write down x minus 1 and x plus 4, and then take whatever the leading coefficient is when it's anything other than 1, I write it underneath. And then I try to reduce. Like 1 over 4 doesn't reduce. So after you attempt to reduce, if you still have a fraction, you have to take the bottom number, not the smallest number, not the largest number, the bottom number, and we say bottoms up. Bottom goes up. Okay? This reduces to 1. I get the exact same answer, and I think it's less time. You choose whatever one works for you. I'm accustomed to doing it this way. It's faster for me. I choose this way. If this way still makes more sense to you, you can use that method. Get started with this very first problem. So this is simplifying rational expressions. Rational just means fractions. Simplifying, we want to put it in lowest terms. And an expression means we don't have an equal sign. We're not solving for x. Okay, what am I going to do? I'm going to start with this part. I'm going to start with this trinomial. And I recognize that 12, 14, and negative 10 are all even numbers. So let's drop down here and let's factor out a 2. When I factor a 2, I get 6x squared plus 7x minus 5. And then I want us to put this curly bracket so we focus only on the trinomial, that's 6x squared plus 7x minus 5. That's the only trinomial I'm looking at. I'm forgetting about everything else. And I make my little x, and I go 6 times negative 5 is negative 30. And I want to know, these are different signs, and the larger number is positive. Okay, so I'm like 1 and 30, that doesn't give me 7. 2 and 15, that doesn't give me 7. 3 and 10. 3 and 10 could give me 7, right? Now, how do I know if the 3 and 10, which one's positive, which one's negative? The larger number is positive. So I need to go back here and make sure. Does positive 10 times negative 3 give you negative 30? Yes and yes. I have found the two numbers. Now you choose to do the AC plus B method, which is right here, or you choose to do what's called the bottoms up method. That is totally your preference. Please go ahead at this time underneath that and please go and factor. One complaint I get from teachers who don't like the bottoms up method is this is where students go. They select their numbers and they stop. And they forget that whenever this leading coefficient of the trinomial is anything other than positive 1, they've got to drop that value underneath. That's the only complaint I get about bottoms up. So I'm going to reduce this. They both are even, divide to give you 5 over 3. I'm going to reduce this, and I get 1/2. Do I leave it like this? No, because I'm not trying to solve. I'm rewriting this in a factored form. So after you put it in simplest form, if you still have a fraction, you go bottoms up, bottoms up. The bottom number, push it up to get 3x plus 5 and 2x minus 1. What I want you to recognize is this is factored form. It is completely equivalent to this original trinomial up front. And in order for us to move forward, you have to put it into factored form if it's possible. So now I'm going to rewrite this, and you're going to do the same. We're going to write 3 over, so this is the original problem that's now in factored form, 2 times 3x plus 5 times 2x minus 1. That is the first fraction, plus 2 over 3x plus 5. There's multiple ways that we could go about finishing this problem. I want you today to recognize when is it to your advantage to use what's called the butterfly method, and when is it to your advantage to use what's called the LCM method. And so I'm going to have Tristan. Tristan, can you choose one? So there's 3 different groups. Do you see this, Tristan? There's 3 different groups in the denominator. Choose one of those groups and just say it to me. It doesn't matter. Go. Okay, does everybody see how you chose this one? I'm going to choose to put one line underneath that. And now I look at the denominator, and all I'm focused on is the denominators. I look at the denominator of the second fraction. Hey, it also has that. I know to add or subtract fractions, I must have a common denominator. I've got it. Okay, good. Everything's balanced. They both have it. Great. Good. Can I have, Belinda, can you choose another one of the groups from the first fraction, and please list it out loud. Go. A little bit louder, please. 2x minus 1. So 2x minus 1, I'm going to put down 2 lines here just to try to make this really organized. But when I look at the second fraction, do we see 2x minus 1? We do not. So what I need to do is, in order to keep the value of this fraction the same, whatever I multiply by the bottom, I must also multiply by top. Okay? So I'm going to go times 2x minus 1 times 2x minus 1. Now, they both have a quantity in the denominator that is 3x plus 5, and they both have a quantity that is 2x plus 5. And I may have said it wrong, 2x minus 1 and 3x plus 5. What am I missing, Miss Gill? What's in the denominator of the first fraction that I have not accounted for? A 2. And I'm only focused on the denominators right now. So I have a 2. That's the third group that we have listed. And I look over here, and in the past, there's a lot of confusion. Students would say, yeah, you have a 2, it's up top. I'm only focused on the denominators. There is not a single 2 all by itself here. So I'm going to add a single 2. Whatever I do to the bottom, I must also do to the top. Now the denominators are exactly the same. So my final answer here, I'm just going to slip this down so I have more space here. Let me give me 1 second. 1 second, 1 second. There we go. My final answer will have a denominator that is 2 times the quantity 3x plus 5 times the quantity 2x minus 1. I'm going to make a bracket on the left and a bracket on the right. We have simply a lonely 3 on the left-hand side. Here's my addition sign, and 2 times 2 is 4 times the quantity 2x minus 1. Only 2 steps left. I'm going to distribute this 4, and I'm going to be lazy about that. I get 2x times 4 is 8x, and 4 times negative 1 is negative 4. So I have 3 plus 8x minus 4. When I combine like terms, 3 plus 8x minus 4, I get 8x minus 1 over 2 times 3x plus 5 times 2x minus 1. This is my final simplified answer. When I see problems like this, I immediately look at that trinomial, and I know I want to factor it. So off to the side, I'm going to see, is this trinomial in the denominator factorable? So I'm focused just on the denominators. If you need to cover up the numerators, then do so. 6 times negative 5 is negative 30. I'm looking for 2 values that are different signs. The larger number is negative. If it's possible to be factored, that could multiply to give you negative 30 and combine to give you a negative 13. So 1 and 30, that doesn't work. Hey, 2 and 15 works. Negative 15 and positive 2 would multiply, and they would combine. So you at this time choose to do the AC plus B method or do bottoms up. Turn to your partner and tell them what method you're using, and then when you get done, compare. Ready, get set, and go. I should hear talking. What method are you using? And now when you're done, compare. Oh, once you get it factored, I want us to continue to do this together. This is the problem a lot of students make. They identify the correct 2 numbers that allow us to get this product and this difference, but they forget to do the bottoms up, since the leading coefficient in the trinomial is not a positive 1. So I'm going to put 6 in the bottom, and then I'm going to reduce this. So, by the way, I want to show you a trick. If you're like Miss Bradley, like, I get the steps, but I forget how to reduce. Grab that calculator. Take 15 divided by 6. 15 divided by 6. Hit math, fraction, enter, enter. It will reduce it for you. So 15 over 6 reduces to 5/2. And again, the exact same thing. If you're like 2 over 6, I just keep making mistakes when I'm trying to reduce. Take 2 over 6, hit math, fraction, enter, enter. It'll reduce it for you to get the 1/3. So if you are somebody who struggles with that, but you understand the procedures, that's what you can do. Okay, so I'm going to do bottoms up to get 2x minus 5 and 3x plus 1. Please help your partner and continue on with this problem. I'll be back with you. Boy, now that if you're watching this video, we had somebody come in, and I know that I'm off task now, and it's gonna be hard to get you guys back on. So I have 5x over this quantity, 2x minus 5, and 3x plus 1. Back on task. If you're in my classroom, make sure your electronics are put away and I do not see them. Christian, electronics put away from you, please. Thank you, sir. Okay, so just like we did about 15 minutes ago, I called on somebody. We are only focused on the denominators, and I asked, choose one. So I'm going to choose 2x minus 5. I can see both the left and the right side have a 2x minus 5. I don't need to worry about that. But on the left side, I have a group of 3x plus 1. I do not have that on the right-hand side. So I'm going to attach a 3x plus 1 to the right and a 3x plus 1 on top. Both the top and the bottom need to have that quantity, not to change the value of the original fraction. So let me grab a new piece of paper that doesn't make it look so messy as we go through this. Otherwise, it's a little confusing whether you're watching at home or in class. I'm going to rewrite this as 5x over 2x minus 5, 3x plus 1, subtract 2 times 3x plus 1 over 2x minus 5, and 3x plus 1. Okay. What do we do once we have that common denominator? I write it down one time, and I make my two brackets, separated in this case by a subtraction sign. On the left-hand side, I have just a lonely 5x. On the right-hand side, I can't use this symbol twice. I've already used it right here, so I'm going to cross it out, and I'm going to distribute the 2 to get 6x plus 2. Now, when I combine like terms on top, I have 5x minus 6x minus 2 when I distribute that subtraction, and I have a final answer of negative 1x minus 2 over 2x minus 5 and 3x plus 1. The next problems that we are going to attempt, these will be valuable as you go through your work, are going to go back to what we talked about with factoring. Let's start with this very first problem. I would like you to write down x squared minus 4 with the 7x on top and x plus 2. When you see x squared minus 4, what does it factor into? Anybody can shout it out at this time. You have to recognize that. What does x squared minus 4 factor into? X plus 2 and x minus 2. Remember, factoring is just an equivalent way to rewrite an expression. Okay, so when I look at the two groups, what do they have in common in the denominators? Awesome. What is the right-hand denominator missing? And whatever you attach on to the denominator must be attached on to the numerator. They both contain an x plus 2 and x minus 2. So that's our denominator. And then I'm going to make a bracket on the left, a bracket on the right, and for this problem, we'll have addition in the middle. I bring down the 7x, and I'm going to distribute this 3 to have 3x minus 6. When I combine like terms, I end up with 10x minus 6 over this quantity. Now, I would not count that wrong. I would not count it wrong. But it's very possible you see this in a different form. Both 10 and 6 are even numbers, so it may also be written as 2 times the quantity 5x minus 3. If I distributed the 2, I'd get 10x minus 6. Either one of these would suffice for this class. We are going to move on now to what do we do if we don't have those trinomials and we don't have the difference of squares? What's an easier way to do this? So here will be my next problem. 7 over 3x squared plus, let's go with 5 over 2x. Now, there's multiple ways to do this. Could we still do the way of finding the common denominator? Yeah, we could. But when there's no difference of squares, when there's no trinomials, I'm going to rely on doing the butterfly method. We're going to do it the same way we did at the beginning of this lesson. We just now have variables. So I'm going to do 2 parentheses. For this problem, it's separated by addition sign. 7 times 2x is 14x. 5 times 3x squared is 15x squared. And when I multiply the denominators, or the product of the denominators, I end up with 6x to the third. Now, a great question is, can I take 14x and 15x squared and combine them? You can't. You have to have the exact same variables with the same exponents to combine those. So I have to ask myself, is there something more I can do? Each one of these can have a maximum of 1x taken out. So I'm going to factor out an x, and I get 14 plus 15x. 14x plus 15x squared. Now, I want to put this in simplest form. That's part of the directions. Simplifying rational expressions. So I want to also factor out an x here. When I factor out an x, I get a 6x squared on the inside. If I distribute it, I end up with 6x to the third. If I asked you what's 2 divided by 2, you would tell me 1. Why is that? Because I divide by 2, and I get 1 over 1. If I asked you what is a over a, we'll divide by a, I end up with 1 over 1. What's x over x? It's simply 1. Sometimes people use the term they cancel out. In reality, really, they're going to simplify down to 1. But if you want to think in your mind they cancel out, go ahead. Okay, when you have the exact quantity on top and bottom, and we're working with products, we can cancel out. This is my final answer. I want you to do one more problem. If you get it right, we're on to doing our homework in class. Here we go. With your partner, please begin. Okay, this is confusing. So I'm going to do the butterfly method here. Now, could we also try to find a common denominator? Yeah, there's more than one way to come up with this answer. So I'm going to start by doing parentheses. Subtraction will be on the inside. I've used that symbol. That's going to be the subtraction. I want to bump this up to the 3. So I'm going to multiply to get negative 9x, multiply to get 10x, and then I'm going to find the product of the denominators, which is 15x squared. Negative 9x and negative 10x is a negative 19x over 15x squared. Now, it is true that 19 and 15 cannot be reduced, but I can see that I'm able to factor out an x. Let's take an x out to get negative 19 over 15x. The x's, if you want to think cancel in your mind, do so, but really, in reality, they're going to be simplified down to 1, and this is my final answer.